Hello everyone, I am Dr. Sirajul Haq. I welcome you in my YouTube channel. Today in this video, I am going to describe Oxazole. You know my friend, Oxazole is an heterocyclic compound and play an important role in synthesis of organic compound. So in this video, I will describe properties of Oxazole, preparations of Oxazole. So let us start learning of Oxazole. Oxazole contains oxygen and nitrogen at 1,3 positions. Here oxygen got position 1 and nitrogen 3. This is important. Now nitrogen is pyridine-like and oxygen is like a furan-like oxygen. You know the furan is also a heterocyclic compound and pyridine 6-member heterocyclic compound. So nitrogens of Oxazole resembles with the nitrogens of pyridine and oxygen of Oxazole resemble with the oxygen of furan. Oxygen's positions 1 and nitrogen position 3. Now look at here. You can see unhybridized p orbital, sp2 hybridized orbital of Oxazole. So Oxazole is aromatic or not aromatic? We have to check some important point related to Oxazole. Oxazoles have 3 carbon, 1 nitrogen and 1 oxygen. All are sp2 hybridized. sp2 hybridization is planar. It makes a planar Oxazole ring structure. Each ring atoms also contains unhybridized p orbital, that is perpendicular to the plane of sigma bond, plane of ring. P orbitals in oxazoles are parallel to each other, so overlapping between p orbital is possible. The total number of non-bonding electrons are 6. 3 of 3 carbon, 1 from nitrogen and 2 of oxygen. So, however, an oxygen atom is highly electronegative, so the delocalization is not overly effective. This is important. Now synthesis of Oxazole. Robinson-Gabriel synthesis. What is Robinson-Gabriel synthesis? This is transformations of open to ring, cyclizing dehydrations, acid catalyzed closure of an alpha-acyl aminocarbonyl compound. Alpha-acyl aminocarbonyl compounds. So this transformation is known as Robinson-Gabriel synthesis. Now, mechanism of Robinson-Gabriel synthesis. Oxygen lone pair of electrons providing their electron density to electron deficient hydrogen, then formations of oxygen and carbon double bond and deficiency on oxygens, then cyclizations, then dehydrations, then deprotonations, and the final product is your oxazole. Another method of preparation of oxazole is from an alpha hydroxycarbonyl components. Alpha hydroxyketones, which is commonly known as a siloine, react with amide. After dehydration, substituted oxazole is obtained. This is another method for the synthesis of oxazoles from alpha hydroxyketones and amide. The mechanisms you can see: alpha hydroxyketosuccinate formamide, it gives diethyl oxazole for 5-dicarboxylate. Ester hydrolysis, barium hydroxide water, oxazole 4,5-dicarboxylate is obtained. And then quinoline, copper on heating, decarboxylations, oxazoles being obtained. Now, third method of synthesis of oxazole from isocyanides. Reactions of isocyanide with acid, chloride, or anhydride yield substituted oxazoles. Isocyanomethylbenzene react with acetyl chloride under Boole. Boole means N-butyl lithium, normal butyl lithium. 5-methyl-4-phenyl oxazoles is obtained. Now, reactions of oxazole. Electrophilic addition to nitrogen. Oxazole is less reactive compared to imidazole because presence of more electronegative oxygen. Another important reaction, protonation, which showing basic properties of oxazole. Oxazole accept proton, act as base, form oxazolium salt. Oxazolium salt, you can see here oxazolium cation under resonance conditions. Now reactions, electrophilic substitution to carbon, less reactive due to oxygen present in heteroskeleton. Reaction is possible at 5th position if ring is activated by electron donating groups. Nitration and sulfonation are more difficult in oxazole. So you can see 2-phenyl oxazole converted into 5-bromo 2-phenyl oxazoles in presence of NBS, N-bromosuccinamide. Important reactions like Diels-Alder reactions act as diene for pi components. Oxygen atom is highly electronegative, so conjugated double bonds are readily available as diene in Diels-Alder reaction. Oxazoles readily undergo Diels-Alder type cycloaddition across the 2,5 positions. You can see here synthesis of oxazoles from oxazole. So oxazole react with alkyne, it gives furan and benzonitrile. Diels-Alder reactions, you can see the formation of substituted furan. Conjunctiva pyridine synthesis from oxazole. Synthesizing pyridine derivative by Diels-Alder cycloaddition between an azadiene and dienophil, followed by an extrusion. This is very important word, extrusion of the resulting breach of bicyclic intermediate. So oxazoles, which is dienophil, azadiene, and this double bond dienophil, it gave the pyridine ring. So you can see here the cycloadditions formations of bridge oxygens, then opening, and then ring expansion. My friend, Oxazole's ring also important related to antifungal agents. So benzoazoles are natural product with two oxazole groups. You can see benzazole A, which contains two oxazole ring, this ring and this ring. Oxaprozine. Oxaprozine is a non-steroidal anti-inflammatory agent. N for non, S for steroidal, A for anti, I for inflammatory agent, used to symptomatically treat inflammations, pain, and rheumatoid disease. So oxaprozine contain oxazole ring. So my friend, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.